All right, let's take a look at a couple of these quiz questions. This one says, what is the similarity ratio of the smaller to the larger similar cylinders? When you come across questions that involve ratios, this A colon B, you need to pay attention to the wording. It's the smaller to the larger. So when you look at these two cylinders, this dimension is for your smaller cylinder, this dimension is for your larger. So your ratio would be 20 to 30. You always want to reduce your fractions, so you can reduce each of these by 10. It would be 2 to 3. When you go to put it into the answer box here, they want A colon B, so 2 colon 3, and hit done. Okay, this is the same type of question. Again, smaller to the larger. So pick one of the dimensions. It does not matter. You can either write 9 to 15 or you can write 6 to 10 as long as you're comparing the same dimensions. For this one, they each reduce by 3, so you'd have 3 to 5. For this one, they each reduce by 2, so you'd still have 3 to 5. Both of these ratios should be exactly the same for the figures to be similar. And then again, when you put them into the answer key, they want the 3 colon 5. And you are done. Now this problem gets a little more complicated, and hopefully you wrote down that flow chart on how surface area and volume relates to similarity. Alright, so for this question, we're still doing smaller to larger. So when you look at our two surface areas here, our smaller rectangle has a surface area of 18, and our larger has a surface area of 50. Now you do want to reduce each of these. So both of them are divisible by 2. 18 divided by 2 gives you 9. 50 divided by 2 gives you 25. Now, surface area relates to your original similarity ratio through a square. So in order to get back to your original similarity ratio, you actually want to take the square root of your fraction. Square root of 9 is 3. Square root of 25 is 5. That tells you that your original similarity ratio is 3 colon 5. Okay, and you could go the other way too. To get the ratio from similarity to surface area, you would square it, and the ratio would be 9 to 25. Alright, for this question we've now moved on to volume, but we're still looking for that similarity ratio, and again, smaller to larger. So our smaller volume here is 250 pi. The larger volume is 1024 pi. In order to get back down to the similarity ratio, you do need to simplify. So the pi's will cancel, and then reduce each number. Both are divisible by 2, and you would end up with 125 over 512. Now, the relationship between the similarity ratio and volume is that you would have to cube the similarity ratio to get to the volume. So we are going to do the opposite of that. We are going to take the cube root, and what you want to do is take the cube root of each number individually. So the cube root of 125 is 5. The cube root of 512 is 8. So our original similarity ratio for these two cones would be 5 colon 8. Now, this question is going to be basically the most complicated one that you're going to come across. The surface areas of two similar figures are 36 and 49. If the volume of the smaller figure, so we have the volume of the smaller one is 648, I want to know the volume of the larger one. Now, the first thing we need in order to figure this out is our similarity ratio. So remember that your surface area relates to the similarity ratio by being squared. So to get back to the similarity ratio, we take the square root. Since that fraction does not reduce, we can take the square root immediately, and we're going to get the square root of 36 is 6, the square root of 49 is 7. Now, again, to get back to surface area, you square the similarity ratio. To get to volume, you take your similarity ratio and you cube it. Now, the volume of our small, whatever. Alright, so the volume of our small figure is 648. And remember, the small is the top of our fraction here. So we're going to fill that in over our variable x. So the first thing you want to do is cube your fraction. In order to do that, just cube each part of your fraction and leave it as a fraction. So we're going to get 216 is 6 cubed, and 343 is 7 cubed. From there, to get x out of your denominator, you multiply by x. We're going to do the same thing over here. So we're going to get x times the 216 divided by the 343 equals 648. Now to get x by itself, you do the opposite of the fraction. So we need to multiply by the 343, which is going to give us x times 216 equals 648 times 343. I get 2,2,2,2,6,4. And then we are going to divide by 216, which leaves us with x equal to 1,029, and the units would be inches cubed. For problems like this, you just have to remember the relationship. Surface area is your similarity ratio squared. Volume is your similarity ratio cubed. This question is a lot like the last one. We are given the surface area of two similar figures as 4 and 9. So to get back to our similarity ratio, we take the square root. Square root of 4 is 2. Square root of 9 is 3. So our similarity ratio is 2 to 3. When you go to compare the volumes, we now have the volume of the large figure is 216. Volume, remember, is your similarity relationship cubed. The large figure is the bottom of our fraction, so we're going to fill it down here in the bottom part of our fraction, and x would be the volume of the similar figure. For this problem, it involves a lot less solving. You do want to first cube the fraction. So 2 cubed is 8, 3 cubed is 27, and then we still have x divided by 216. From there, all you want to do is multiply by 216 to get it out of the denominator. And if you don't have a fancy calculator, just type in 216 times 8 and then divided by 27. And I get 64 when I do that. So the volume of our small figure is going to be 64. Again, just using those relationships between the surface area being the ratio squared and the volume being the ratio cubed. Alright, this is going to be the last example that I show you. This time we're given the volume of similar figures is 729 over 2,744. Now remember, volume is your similarity ratio cubed. So the first thing we want to do here, since nothing reduces, is cube root each one. The cube root of 729 is 9. The cube root of 2,744 is 14. So our original similarity ratio is 9 to 14. Then you can set up your fraction to find surface area. Surface area is your original similarity ratio squared. And it tells you here the larger figure is 392 for surface area. So we're going to put it down the bottom here, 392 for your larger, and x in your numerator. Now to solve, first thing you want to do is square the fraction. When you square it, you will get 81 over 196. That's going to equal x over 392. To get the 392 out of your denominator, you multiply. And again, it's 392 times 81 divided by 196. I get 162 for x. And again, it's using that same relationship over and over again, that your similarity ratio squared represents surface area, and the similarity ratio cubed represents volume. From there, you just set up your proportions and solve. I hope this helps. Let me know if you have any additional questions.